Tutorial sheet 4, question 7. When a superhet receiver is tuned to 555 kHz, its local oscillator provides the mixer with an input at 1010 kHz. What is the image frequency? So what we have here is we have our antenna going into a single stage mixer. So the RF frequency is equal to 555 kHz, and the local oscillator frequency is 1010 kHz. So first of all, we need to calculate what the IF frequency is. So the IF frequency is going to be the difference between these two signals. So that's going to be 1010 minus 555, which is equal to 455 kHz. So our image frequency, because our local oscillator is greater than our FRF, our image frequency is going to be above the local oscillator frequency. And it's going to be above the local oscillator frequency by the IF frequency. So our our F image is going to be equal to our local oscillator plus our FIF, which is going to be equal to 1010 plus 455, which is equal to 1465 kHz. So that's our image frequency. The next part of the question says the antenna of the receiver is connected to the mixer via a tuned circuit whose loaded Q is 40. What will be the image frequency rejection ratio in dBs? So rather than going directly into the mixer, we're going to be going via a tuned circuit or a filter. So there's going to be a filter in at this point. So we need to recall the equation for how to calculate the image frequency rejection ratio, which is equal to the square root of 1 plus Q squared X squared, where X is equal to the ratio of the image to the signal frequency, subtract the ratio of the signal frequency to the image frequency. So in our case, our image frequency is 1465 divided by our signal frequency, which is 555, and we subtract the opposite ratio. And if you do that, you get 2.261, and you put that into this equation, so you get the square root of 1 plus our Q. Well, our Q factor from the question is 40, so it's 40 squared multiplied by 2.261 squared. Calculate that and you get 90.4. That's in linear terms, so in dBs, that's because this is a voltage ratio, it's 20 log 10, 90.4, which is equal to 39.1 dBs.